Hello, good morning, good evening, Swift community. This is the Swift server meetup number 7 already more than a
It's been
year.
Almost 2 actually. We've been going for a while
we're
now.
finishing the second year of the Swift server meetup, and it's the last meetup of the year. Obviously, it's a December, but we will continue next year once every quarter. So hello everybody. Just like we have an habit now, drop a message in the YouTube comment and let us know where you are based, where you are connecting from. If you are watching us live, of course, I know that the majority of us will watch us offline a bit later in the coming days and weeks. We have Maddie, which is there. I'd love to meet
Gregorio,
you, Maddie.
hello.
You're someone that I'm talking frequently on GitHub, but we never meet to each other. We have Gregorio. We have Tim from Manchester, we have Egypt, we have Frank from Paris, Carlin from Italy, Stephen from Ghent in Belgium, Bristol, Halifax, Canada, Ottawa, Canada, India. Wow, it's late in India. Thank you for joining.
Doug from Ottawa.
That late as well. So familiar face, thank you for being here. Last week I was at reInvent, the AWS conference in Las Vegas, and we had the surprise to have an Apple VP on stage during one of the keynotes. It's Payam Mairashidi. He's VP of Cloud Systems and Platforms at Apple, and he had like a 10-minute segment in one of these big keynotes we have typically during this type of conference. And he talked a lot about Swift and Swift on the server and how Apple is using Swift on the server. He mentioned that many services from Apple are implemented in Swift, running in the AWS cloud on the server, serving billions of requests per day. That's the metric he mentioned. And talking about Graviton and talking about the different ways to deploy Swift application on AWS. So the link, if you want to watch this segment, is here. It's on YouTube. I put the exact time code where Payam start to talk, so you don't have to watch the entire keynote. That's quite interesting. It's not very frequent that Apple is talking about their infrastructure and what they are doing with some of their providers, such as AWS. So it's quite interesting to watch. What's your highlights, Johannes?
Yeah, I mean, we were at Server-Side Swift conference in between the previous edition and this one, right? And I was really happily surprised by the Swift temporal library, not just because it's an interesting ecosystem to have as part of the Swift community. I also really like the temporal people coming to the Swift conference, Swift server conference. Mm-hmm. But on top of that, I dove into the design of that library. And the lengths that they went through to make it deterministic is very impressive and shows how powerful the Swift programming language has become.
So that's Swift server side, and most of the talks are on YouTube as well. So if you search for Swift server side on YouTube, I will put the link a bit later. Today we have 2+2 guests. We have 2 demo and talk from people that you might know in the community. Andrea is going to talk about Swift serverless backend and Breeze, and Moritz will show us how to deploy code with Swift. Deploy code on the server. And then we have 2 last-minute guests, and I'm super happy to have you folks, Matthew and Adam, that will take any questions you might have about Visual Studio Code and more specifically the Swift extension of Visual Studio Code. So what we are planning for later...
questions for the VS Code extension right now or during the talks, just put them in the chat and we'll cover them during the later stages of this meetup as well.
And what we are planning to do, probably Q1 next year, is to have a full session with them to have like a demo of the Visual Studio Code extension, because I know I'm using 10% of what the extension is able to do, probably always the same 10%. And there are so many different ways to use that extension. So that will be cool. That's for Q1 next year. Anything else to add before welcoming our first guest, Johannes?
I don't think so. Let's get started.
So, first guest, someone that we know quite well in the Swift server community as well, Andrea, you're based in London, and I let you introduce yourself. The stage is yours.
Yes, thank you everyone for joining. Thank you for inviting me. I'm very happy to be among friends, even if it's virtually. I'm Andrea Scuderi. I'm senior iOS engineer at Just Eat Takeaway. But today I'm going to talk about a side project which I started in 2019. And thinking back 6 years ago, is amazing how the backend in Swift and then serverless has evolved. When I started this project with Lambda, there was no support for Amazon Linux. There was no support from AWS. It was treated as a secondary language. So I'm very happy to have seen Apple on the stage at reInvent. So let's get started. So the story is about showing how it's possible to build a mobile app in Swift and with a serverless backend in Swift. And we will see this app. It's a very basic demo app that present how to query a REST API with a CRUD implementation. Then I will go through the app and the serverless architecture. I will show you the code, and then I will introduce Breeze, which is a tool I created during this year to make easier to deploy a simple application like that. And will generate some code, and also it will generate the scaffolding to deploy the project on AWS. And then I will go through some final consideration. Okay, full stack Swift. What I will present is a demo app. Is in Swift UI. It uses Apple sign-in to sign in inside the app. And then the backend is made with Lambda in AWS, and so is using a serverless API. This API can create, read, update a form, and a form is just a way to avoid the usual task list because it's a little bit more complex. You will see that after. So let's see how the app works, and then I will explain how it has been made. So first of all, I log in inside the app with my account, iCloud. Once I'm in, I can tap plus and I can start inserting a new form. You can see that there are 3 different kind of field: optional field, mandatory field, and text field. So in this case, those are optional. These are the upper are mandatory, right? So let's insert some text and I submit. Good. So I inserted my first record. And now I want to update it. So I will change some text here. Yeah, just some random stuff, and click update. And we changed our record. Now I add a new record. I want to show you how the list appears when we have more record, but also at the end, I will delete the record. And basically that's it. So we have seen that we can create, read, update, delete, and also list a form from our app. Important things you need to notice is that we have for each entry we have a key, a created at field, and updated at field. These are very important because they are needed to store our record inside DynamoDB. I will see later. First of all, let's start with the data structure of our form. The form, as I mentioned, has those fields plus a name and a list of fields. In addition, in each field, we store the question, the answer, the choices, the field type. So as you can see, the form type is a codable structure, which is quite convoluted because there is a nested field, there is enum. So it's a typical codable with a lot of information inside. What we will do is to store this information in DynamoDB. DynamoDB is a serverless NoSQL database, a key value database in which we can store key value information. In this case, we call the table forms table dev. Our key is called the form key. On DynamoDB, you can provision the amount of read and write that you can do per second. In our case, this amount is not defined, and we want to scale up on demand. Once we insert a record, we can query. And how the record look like? It's a kind of JSON, but as you can see, is not exactly the JSON that we obtain from Swift, because on Dynamo there is also the specification of the field type. For example, S is a string, and so on. So what we want to do is to store our JSON in this format on DynamoDB. Let's go a bit back. From the app side, from the client point of view, there is no special difference from another kind of backend. We have O2.0 provider, which in our case is Apple sign-in. The mobile app will require a JWT token after sign-in. And with this JWT token, we'll ask a request to API Gateway, and API Gateway will respond with a response. So from the client perspective, there is nothing special. On the backend side, there is a map between the endpoint that we share on the internet and the Lambda. Let's discuss a little bit this architecture. So Amazon API Gateway will expose on the internet 5 endpoints in our case. And for each endpoint, there is a mapping with the Lambda. The Lambda is an event-driven computational power provided by AWS. It's event-driven, is stateless, and reacting this way. Once we receive a request from Amazon API Gateway will trigger an event in the Lambda. The Lambda will perform an operation on DynamoDB and will respond to the client. So this is the architecture of the backend. The cool things of using Swift in both client and server is the fact that we can share the structure of the model. So I pointed out in this slide as the shared model. In this shared model, we just put the codable structure that we can use on the API client, which is on the left, where we have our app. And on the right side, we have the code that is running on Lambda. Lambda is an executable which run using the AWS Lambda runtime for Swift, and it will depend on 2 packages, one to create the Lambda API and one to interact with DynamoDB using Soto, which is, again, another SDK for using AWS services written in Swift. Let's have a look to the code. So this is the API client. The API client implements a service to call our API. And it specialized the Breeze Lab API client, the generic with the feedback form that we want to show in our app. We will get from the session the JWT token, and what the API client needs to do is to pass the token when calling the API. Once we deploy our backend, we can set up the environment of our API client, and we need to put there the base URL. We will be back there, here once we deploy the backend. Okay, so now we have the architecture. We know what to do with the client. Let's see how the serverless code looks like. And this the big surprise, because we have here just one line of code in which we pass the form, which is the shared model, and we just call run. The only requirement is that the form is conformed to Breeze Codable protocol. And as I mentioned before, it's just the fact that we have the key, the created at and updated at fields. Those are required, the key to, of course, to have the key in our DynamoDB. Created at and updated at are needed to use optimistic concurrency, which means that you cannot update a field that if you don't have the right value of created and updated. So if you don't have those value correct, the only things you can do is retrieve again the record from the backend and then try to perform an operation. Okay, so we have this was our code. One question could be, we've spoken about 5 lambdas, right? But I'm just showing one. And that's the trick, because with this one lambda, we can specialize the lambda at deployment time. At deployment time, we can say the act as read, act as delete for each lambda. So we have only one single lambda that we can reuse in 5 different points. But the instances are 5. So now we need to describe our infrastructure, and we do it using infrastructure as a code. And in particular, I'm using serverless framework. And in particular, I'm using the open source version of it, because the new one is paid and they change a little bit of things. So there is an open source community that is maintaining the serverless framework. In all of this kind of infrastructure as a code tool, you need to describe what you want to deploy. In our case, is the API gateway, the Lambda, DynamoDB, the permission, and of course, we need to specify where is the package containing our build that we want to deploy. As you can see here, there is a lot. This is coming from Visual Studio. Everything is collapsed. It's a very long file, and it's very hard to make it right. So one of the things is that I thought during this process of refactoring many times this code was that it's very useful to have a command line tool which will generate the whole scaffolding of the project folder with the Swift package, with the serverless.yaml, with build script, with deployment, just having a single file, which is a configuration that you see on the right. And in this file, we specify which region we want to deploy our service, the service name, how we want to call the package, the target, how we want to call the classes, because all of this information are partially inside the Lambda and partially are inside that serverless.yaml. So to do it right is not so easy. Important thing you need to notice here, for Apple sign-in, I just add the bundle ID in the audience, and that's it. So once you configure Apple sign-in from the Apple portal, the only things you need is your app bundle ID just to implement the security. So it's very convenient, and this is thanks to API Gateway that manage the security for us. This is how the help of the Generate Lambda API looks like. I will not spend that much time, but this is how looks like the generation of the code. Once the code is generated, you will see this nice logo, and then you will see how to run the deployment. Important things is that we now got our project generated from Breeze command line. Inside the project, you will get an example of the form with the minimum amount of code needed. In our case, we moved the form to the shared model that you see below, but all the other things are prepared for you by Breeze. So the serverless.yaml, the makefile, the bash script to build, deploy, and remove, and also to update. So everything is already there. So let's go to the build phase. We cannot use Xcode because we need to build our binary for Amazon Linux. Now, as has been mentioned, we support also Amazon Linux 2023. You can just change it from the serverless.yaml, the deployment target. We support Graviton and also Intel. So, of course, I suggest to use Graviton because it's cheaper and it's also faster. So, the build will require only to have Docker in your machine. And once you run it, and we will run it now, so it will take some time because the first time we'll need to download the image from Docker. Once the image is downloaded, it will start building the Lambda. And once the Lambda is ready, I'm going faster, but at the end you will see it took around 3 minutes and 20. Once you complete the Lambda building, you will get where the Lambda zip file is put. So once we have the build, it's time to deploy. Requirement for deployment is, of course, to have a serverless deploy from open source serverless, the serverless.yaml, the build that we created, and you need to set up on AWS your IAM credential to make sure that you can deploy with serverless. To understand what are the credentials, I suggest to go to serverless GitHub because they have a README on how to configure the credential. Sometimes it's challenging, so when you get to the deployment and you get an error, just read the error, and most of the time you understand which permission you missed during the deployment. So let's see how the deployment works. So I started the deployment script here. No, I think it's small, but it's uploading the CloudFormation stack created by serverless framework. And after a while, you will get the list of endpoint created by the implementation of the infrastructure as a code. And that's it, because the last thing you need to do is to copy one of the base URL without slash from this list and copy this where we see this API gateway base URL. You copy that, you run your client, and everything is up to ready to go. So we spent 3 minutes to build the Lambda, 3 minutes to build, to deploy the serverless. 10 minutes, you have an API client ready. Let's recap the development workflow. So, of course, you can download and try the demo app. But if you want to try your own one, the flow is to clone Breeze, then copy a README file into some of the example of that you find in the README in the breeze.yaml. Also in the Breeze repo, there are 3 examples, so you can check how to do the .yaml. And important things, make sure that you authorize your API. Otherwise, if you don't put any authorization, your API will be exposed on the internet, which is not a good idea. Then adjust the configuration, rename the classes as you want. I suggest the first time just try it as it is, and then once you understand how it works, change the stuff. And then you can build and deploy your serverless environment. And in the end, once you have the endpoint, you can use your client with Breeze Lambda API client. And that's it. Very, very, very simple, I think. Let's conclude with some consideration on serverless Swift and Breeze. Okay. What I didn't mention is the fact that with Lambda, you don't need to set up any specific environment. You just define how the Lambda works, and AWS will scale up and down the service for you depending on the amount of requests that you receive. Of course, there are limits. You can check with AWS, but it's quite a thing. So from day one, you build an API which is scalable up and down. You don't need to think about provisioning virtually in computers like EC2 instances or Kubernetes. So you don't need to manage all these things. So you don't have too much operational overhead. And that's why it's called serverless, not because there is no server, but because there is no management overhead. And the cool thing, and this is, I think, is the selling point of all of this, is that you pay per use, which means that if you do a small service, if you, for example, are an indie developer, you don't need to pay, because there is a very, very generous free tier, 1 million of call per month to your Lambda environment, which most of the time ends up with a very small bill, sometimes even zero. So this is very, very interesting because you can explore ideas. Also, if you work in a company, you can do something for a small department. And the good thing is that you use the Lambda, especially when you have non-predictable workload. In this sense, we can say that it's faster to get to the market because you concentrate your logic only in writing Lambdas, and Lambda is capable to interact with any service on AWS. So technically, once you are able to run the code on Lambda, you can do what you like on AWS. Okay, let's spend some word on Swift. I'm an iOS developer. I do work every day doing front end, and I love writing in Swift. So for me, going on the back end and having the same language is a very, very big stuff. And it will, the language you use every day is the language you are more proficient. So it's possible to change language, but it's also non-desirable when you have a lot of code, when you write fast in a specific language. In particular, we have discovered how important is Swift on server side, because it's memory safe, which means you cannot really access the allocated memory location. You cannot access array out of the indexes, and so on and so forth. And it's very expressive, and you have seen how with a single line of code we span up the entire database and the entire services for the lambdas. And it's fast because it doesn't use a garbage collector. So reference counting will give predictable performance on the server side. Let's spend some word on breeds. So when I first started looking at Lambda, I realized that it's very difficult to get it right for the first time. You need to know a lot of small details. So I use breeds as a way to make sure that first for me, but also for who is interested, you can quickly remember how to do something, how to set up a project, and make sure that you build with the right parameter from the very first time. The cool thing is that everything is open source. You can change the code as you like. It's modularized because you can pick and choose what you need. Let's talk a little bit about performance. Performance of this kind of example are dependent, of course, on DynamoDB performances, because any language will call DynamoDB will have more or less the same performances, but also on the performance of the Lambda. Performance of the Lambda are, you need to understand that there is an initialization phase when a Lambda receives an event, and then an execution phase. During the initialization phase, the Lambda will start the container, will start the runtime, will start loading the code. So the smallest you get the binary, the less you will take in this initialization phase. Once the initialization phase is completed, the Lambda will execute your code. Now, the good news is that the execution phase, it's always guaranteed after the initialization, and the initialization will happen only once. Once the Lambda is initialized, it will start an event loop in which we receive a lot of events and will start only the execution. So this is important to understand the difference between cold start and warm start. So in our case, here I logged the whole cold start lasted 1 second and a half. 200 milliseconds was the initialization of the Lambda, and 800 milliseconds was the invocation of the Lambda, which means also the time that the Lambda spent on Dynamo to do something. Amazing thing is that we get in the warm start, when the Lambda is already warmed, to 11 milliseconds, because the initialization doesn't happen. In our case, probably Dynamo was already caching the response, so it took very, very few milliseconds. Before I go there, so of course, 1 second and a half, it's a lot. And there are ways to improve this. One is provision concurrency, which is quite old. It's basically pay for keeping warm the Lambda once they start. The other option, which was presented last week at reInvent, is to pay for dedicated EC2 instances in which you run your Lambdas. So there are ways to get to the to very good performance and avoid the called start problems. Since I started Breeze, the very first package was the one I presented, but now I added 2 more stuff. One is another subcommand that will allow you to generate webhooks, one for post and one for get. And for example, you can create a dynamic website generated from the Lambda. Another use case is to have a GitHub webhook. The difference with the previous one is that when you receive an event from in a GitHub webhook, you need to validate the origin of the request. So it contains the validation for the secret that you get from Git. And also what I did was to split the packages in different sub-packages, so you can use those packages in your project without using Breeze if you don't like to use it. And I added also documentation on Swift package index. There is support for Swift 602, the Swift concurrency is implemented fully. It works on Lambda Runtime 2.0, and under the hood, when you use Dynamo, you use Soto library. And there are also the demo app, the API client on the repository. You will find out also some package to translate from Swift to serverless .yaml file. I also recently wrote an article on how to set up your environment on Visual Studio Code with dev containers, so you can test AWS using local stack. You will find everything in this repository. And here are my links. So I suggest to get to my blogs because I wrote there most of the content that I presented during these years. And that's all from me. So thank you for listening. And now I can answer your question if you have.
Thank you very much
for the presentation,
Andrea. Yeah. I really like this opinionated framework that helps to reduce the number of lines of code. You have to write like 1 line of code, create an API based on the data structure with a REST API and a backing database. That's really awesome. I put the links to your GitHub and your blog. They are on YouTube. You can just click on YouTube if you want to save that. We have 2 questions so far, so feel free to drop more questions.
I believe they were answered through the presentation, or we can still highlight them
on YouTube. I have 1 question for you. You mentioned authorization, and you stress that it's important to not publish an API without authorization because it will be spam. It's not a matter if, it's when. It's a matter of hours, typically. So what are the authorization you support? I guess the typical JWT, but IAM as well.
So the authorization is the authorization that is provided by API Gateway.
Okay, so JWT, IAM.
There is no idea of authorization inside the Lambda.
Okay.
So from API Gateway, you can have the authorization used on JWT token, but also you can have the authorization using Lambda Authorizer. For example, I use the Lambda to authorize in one of my app because you cannot have like a third-party authentication. So you need to create some kind of secret within your app and your backend to make sure that you can authorize the Lambda. So what I do is I have a Lambda authorizer, I get a JWT token, and then I use that for unauthenticated endpoint, let's say. So the cool thing is you don't need to think too much about the authentication because you can just delegate to the API gateway.
There's a question from Alexandre. Alex, sorry, I pronounce with my French accent. What are the local testing options before the upload?
So before you upload, if you go to my packages, especially the one with Dynamo, you can use local stack, which is a mock of AWS. And if you go to those packages, you will see that there is a one kind of 99% code coverage, because what I do is I test the call to Dynamo using local stack. So before I deploy, I'm 100% sure that it's gonna work. I mean, of course, it's not a full integration test, but you have a good confidence that you can deploy. Most of the time, Seb changes the runtime, and because I have a lot of tests on my side, just check that everything is okay and just deploy because everything is fully tested.
Question from Michaela. Hello, Michaela. What are the benefits of using AWS Lambda for making separate function for create, read, update, delete, rather than making a Vapor or Hummingbird server, or even a big monolithic Lambda function as well? We can extend the question a bit. That's a good question. Why the granularity of one function per operation?
Yeah. So first of all, granularity helps you to helps about observability. Imagine you have one Lambda that is failing, but not all the Lambda are failing. So you can have only, for example, a bad code in the update, but all the other are going well. So this is the first motivation. Second is, and this, honestly, I haven't proved that. I don't know how big is the size of the Lambda using a third party, another framework to basically implement a routing that you don't need, because the routing is implemented by the API gateway. So if the size is similar, there is not much difference. But if the size in terms of megabyte that you upload to run the Lambda is different, there is of course something, and you will see it in the cold start, especially in the cold start. So what is suggested when you do this kind of thing is to test, do your test, check if it's faster in a way or in another. There are also ways to kind of split the code that you upload on Lambda by using layer. But then there is the cons of like dynamic loading framework. So the suggestion is test, real use case. I wrote an article, and you will find in my blog, on how I tested the performance against different languages. And there is some example on what you need to look at, but you need to do some work. This is my
my take on AWS Lambda versus Vapor or Hummingbird. It's a matter of portability. If you want to move your app easily to a Docker container running to another AWS service like ECS, EKS, or another cloud provider that supports Docker, then of course Vapor and Hummingbird are the choice. With Lambda, you probably reduce the price because you don't have to have the application running 24/7. It's per request. So for applications that are not using constantly, you will pay less, but of course there is a bit more stickiness to the cloud provider and the specific API of Lambda.
That also
And of
depends
course,
on how you structure the code, because if you structure the business logic independently from the, let's say, the initial part when you decode the payload, or when you route the payload, you can reuse that more or less everywhere.
Any desire to support other cloud provider or cloud function on GCP, for example?
Not really.
That's a hard one.
I mean,
it's not just supporting. I mean, it's
I wrote the
total
runtime.
rewrite. Yes,
I wrote the runtime for OpenWhisk, so it works on Lambda. It works on Swift 5 dot something, but I didn't see many traction from that kind of project. So honestly, I prefer Lambdas, because once you unlock Lambda, you unlock AWS, basically.
Yeah.
And then a good question from Sven as well. I recognize you from the icon, Sven. You mentioned that you can run EC2 instance to avoid cold start penalty. Are you back in server full LAN then? Are there other ways to keep the Lambda warm? I can answer maybe on the first part of the question.
Yeah, that's for Seb.
So you mentioned, Andrea, that new thing that has been announced last week called Lambda Manage Instance. So it's Lambda function running on EC2 inside your account. And no, it's not server full as then, because it's the Lambda service that will manage this instance. So it will instantiate them, install whatever they need to install, patch them, maintain them, scale them. You just see them appearing in your EC2 console, and you pay for them, of course. But it's fully managed. So it's still serverless. As Andrea mentioned, serverless doesn't mean no server. It means no server to manage, which is a big difference. And so these instances are managed, and your Lambda function runs 24/7. You pay for the instance. You don't pay per invocation, per running time of the Lambda function. So that's the big news for those of you that have constant you know, when your Lambda functions start to cost more than it would cost you an equivalent ECS, EKS, then it's probably a nice alternative. However, and I will be brief because Moritz is waiting and we should continue the meetup. There is a big change with that model, is that now your code can be invoked concurrently. So the same Lambda function running on the same EC2 instance can handle multiple events in parallel. So your code must be aware of that and must be able to run concurrently. For example, if you open a file in /tmp, you have to pay attention that every instance will use a different files. Any global mutable state is dangerous. So you cannot do it with the compiler. You cannot have global variable. The compiler will catch that for you in most of the case. But you have to be aware that your code will run concurrently. So the Swift Lambda runtime currently runs on managed instance, but it processes one event at a time. So you will not get the performance benefit or the cost benefit from it. And we are working on the change that will allow to process multiple events, and that will be released in coming days or weeks maximum. So it will be supported really soon. And maybe you want to add something, Andrea?
Yeah, no. I mean, you know better than me how it works. When I heard that, I said, okay, finally, there is an alternative for the people that are paying too much because the service is too big to have a kind of baseline in which everything works as expected. So very, very, very cool things are coming.
Yeah, there are tons of new things on Lambda, like durable function that can run up to 1 year as well, and multi-tenant Lambda as well, where you have execution environment separation per tenant. If you are creating a SaaS application, for example, you will have different execution environment for different customer for the same Lambda function. That's pretty cool. Thank you, Andrea, for your talk. I love to see, again, I repeat myself, this type of high level frameworks or tools that help you to to reduce the amount of code you have to write, makes it easier. I think Michaela mentioned it, to make it easier to deploy to a cloud provider.
Mm-hmm.
Next on the agenda, Moritz.
Yes. So
good evening, good afternoon. Thank you for being here. And still in the idea of deploying, another way of deploying infrastructure on the server. That's your topic. So I can see right now your GitHub screen. You have slides as well?
Yes, perfectly fine. So we just talked about reducing code to write. I'm actually found out that you might have to write some more for this one. But nevertheless, I wanted to make sure that I start this first because this is going to take a few minutes. So what I want to do, I'm going to deploy to production. And you can see it in action right now, but this will take a little while. So I will get back to my presentation or start my presentation. But first off, this is what the one click is all about. You have to decide which kind of version you want to release, major, minor, or patch. And since this is a major release for me, or a major event, I will just do this one. And this is, of course, on server
Swift server meetup.
Oh, what's it?
It's great to start a presentation with a release. That's cool. now
yeah,
I'm curious to see what's going to be in the release.
So this is the project that this was borrowed from a project that I had. I made it a little bit smaller, and you can see it might take some time. So that's why I'm going to start it now, and you can see it. It's already starting, and hopefully it's not failing. But never did anything go wrong live, right? So let's start with the actual presentation. So building a complete server deployment pipeline in Swift. This is my topic, and my name is Moritz. It's a difficult name for many languages, so anything that has something to do with more and Ritz crackers is fine. And with that, about me, I'm based in Germany. I work at Arconsis, and this is a great company, small company, but I do have a fight to fight every day there because, of course, all the server-side languages are normally TypeScript, JavaScript, or Kotlin, and not Swift. And this is a pain for me because every time I try to argue anything about it, it's very difficult for me to hold my grounds. But today, the pipeline at least is all in Swift. And yeah, my biggest problem actually is I have too many things in my head and too many side projects. I love to host different things, and I'm big into the self-hosting and automation stuff. And my brain is just not big enough for this. So I use automations as my second memory or second brain. And this works out actually pretty good. So the demo project that you saw in the background, this is actually something using Hummingbird. I switched from Vapor to Hummingbird a few months ago or a year ago, and this is the example project from the official Hummingbird example GitHub repository. It's a simple to-do app with a little tweak because I needed to have two services, or I wanted to have two different services. So this one uses the Postgres server as the persistent layer, and the main issue is, also the main server is just copy and paste from the Hummingbird example projects. If you're not familiar, there are some amazing things to get started with Hummingbird, just letting you know. And I'm, of course, using Hummingbird 2.0. And the app is very simple. You have this normal to-do things, which is get, post, and delete. And then I do add a health check and a version, which comes in play when I run all my pipelines. And the health check basically just tells me, is the connection to the database valid and is it working? And does the server run? Because otherwise it won't give me anything back. And for the version, this is a little bit interesting. We can have a look at it later on. I have a normal version number scheme. So you have major, minor, and patch. And then there's also build number, which is the number of commits you will have on main. You can calculate somewhere else, but you cannot use the code for it. You have to use something that Git provides or wherever you want to get your build number from. And yeah, everything is packaged into a Docker image and of course is deployed with Docker Compose. As I said, the persistent layer is using Postgres, and I have two environments that are defined in GitHub, one staging, one production, and they're also on two different servers. And I can show it to you right now. Let me just get this out of the way. Oh, there you go. Of course, live demos always work. So where's my, so I have staging right now. You can see if I pretty print this and make it a little bigger. You can see I have a version, the environment, and the build number. And this is also true from production. And pretty printed. Right now it's the same because the last thing I did was deploy it to production just to see if it works. But as you might can tell, it hasn't worked yet. But that's no big deal. We can get back to this later on. And there you get your presentation back. All right. So why use Swift? Well, we all love it and it's easy and it's fun, and I seriously don't like Bash. It's just a pain. Luckily, we do have AI to help us with it, but it's just, if I read it after 2 days, I have no idea what it's doing. And with Swift, I just know what it's doing and I can get on with my day. So Swift it is. And everyone can understand it, at least in our surroundings. So as we said before, it's type safety. And the awesome thing is GitHub supports it. So any action that is running using an Ubuntu runner will actually have Swift installed. Not quite sure about the version, but most of the things I tried are working fine. And if not, there are always containers that can use the Swift. Yes, what I did in this project, I have 18 Swift-based GitHub actions. They are all, oh, okay. Sorry for that. No. All right. I have 3 workflows. Workflows and GitHub actions are 2 different things. Workflows are a combination of different actions, and the workflows actually decide on what to do and run the different actions in sequence. And for the CI YAML, it's actually pretty simple. It's just a test. This is not connected to the deployment itself, but it's connected to every pull request that will be merged. There will always be a security scan. There will always be SwiftLint tests, unit tests, integration tests, and only if this is done, then you can merge it to main develop where you will live. And this is important because otherwise the whole pipeline will stop at a very early point. And then we have deploy to staging or deploy staging. This is automatically triggered with every commit that is committed on main or develop wherever you want to live. And this basically gets the version, gets the build number, It does not change the version. It does increase the build number on every commit. It builds and pushes a new Docker image, and then I will tell my server, hey, get the new image, and then there are some health checks, and also a 5-minute live monitoring to make sure it's actually running correctly. And I have a little bit more detailed sketch of this, but this might be a little bit much. That's why I put it separately, because there are quite a few different steps for all the deployment to staging. So of course I have to check out the branch. I have to calculate the build number. I have to build the Docker image. All those actions are written in Swift. We'll have a look at it in a little while. Then deploy to staging server is also written in Swift. And then you have a health check. I run API tests. Those are also written in Swift, which is amazing because, well, there are so many other things you can do, and everything is Swift, which is nice. The rollback, I did not, I commented out for this one because it has a few more logic things that don't really work for the simple setup, but anyways. Then I have the post-deployment monitoring. This will only run if there are actually changes in the app itself, and they will run for, I had it set to 5 minutes, but they can run shorter or longer, and it will keep firing on the server to make sure those things are really running and there are no mistakes and nothing happened. And then after that, the deployment is successful, and of course the pipeline is also successful. All right. Then the third one, which might be the most interesting, might also be the one why you all joined us, is the one that actually is supposed to deploy the server. And this one is, as you saw before, triggered manually. You have to decide on what kind of version you want to deploy, if it's a minor, a patch, or a major. And you can also add a little bit of text to it. It's sadly, GitHub is a little bit restricted because it's a one line. You can put a lot of text in there, but you will probably not be able to read it correctly. But as far as I know, you can edit it later. And with that, it's a little bit more complicated, but nevertheless, I will create a release branch, all with Swift. I deploy to staging first. I do the health checks, the API tests, the monitoring. If staging is running correctly, then I will do the same thing for the production server and deploy the image to production. And of course, afterwards, also do a production test. The 15 minutes was nice because I could actually see if the server is not running anymore. Yesterday or the day before, it crashed after 10 minutes. Today, I tried to put it down to 5 minutes, but yeah. And of course, there should be a rollback when everything fails. Then, why am I? Okay, let's do the same dance for the deploy to production workflow. So it's a lot of steps are actually copied and pasted, but there are slight differences. So first, as I said, you have to trigger it. You have to say which version you want to have, and you can do a little description. Then we first have to create the release. We have to find which version we're actually doing, or calculate the new version, do all the Git magic. And then, why can't I? There you go. And then we start the whole thing with deploying to staging. If that works, all good. If it doesn't, then we stop. There is a possibility to add from GitHub to add a manual approval gate to make sure that it will only So it needs an additional approval to actually deploy to production, which I thought is really nice. I disabled it for here because I just wanted to go through it and hopefully show you a positive outcome at the end. But spoiler alert, we already saw it failed. But nevertheless, here are also a few things that will happen. But without further ado, I think we will just jump into the code because I think that's more interesting than anything else. So the core principle is very, very easy. You need to define an action YAML under GitHub actions, the name of your action, and then action YAML. And there's basically one line that actually does everything, and the bash script, one-liner, to change the permission for the Swift script and then run it with the arguments passed in through the action YAML. And it's very easy to not mess it up because YAML is there to help you, which you probably have never heard before. But I like this a lot. And I hope this is not too small. So this is just the smallest GitHub action I could find in my repository because all the others are a little bigger. And you can see you have a name, you have a description, you get inputs, which means you can also describe everything. And the end line down here is you just have one line that you will run. You change the permission, and then you pass in the arguments that were passed into the action. So you can't do anything wrong here. If you configure it once, it will always run because GitHub will slap you on the wrist if you do something wrong with the GitHub action. But this is all nicely wrapped into this action YAML file, and therefore should not cause any issues. And then, of course, you have the Swift part. So the argument parsing is easy. And now we are in the Swift world. You get the argument at the beginning, and then you do whatever you want. You can basically, yeah, you're now in familiar grounds, and now you can use Swift wherever you want to go. And this is actually amazing because then you don't have to care about bash. You don't have to care about anything. All right. And with that, so now I do have, a little idea. So I do have a few tests, do have a few actions that I would like to show. There are quite a few of it. And I would love to do all of them to show you, but GitHub repository is public, so you can have a look at it. But you can, of course, also have a choice. Maybe someone is very active and post something in the channel, so we can get this done. Those are all the actions that I have right now that might be interesting. There's one special thing right here, that's the server management. This one actually is not executed directly in a GitHub action. This one is transferred to my server, so the server can do stuff and doesn't have to do any bash scripting. And this one will actually then stop the Docker container, pull the new image, and then restart the Docker Compose. And so this is something, they are pretty big. We can have a look at some of them if you want to. So for this, create release branch, I already see. API test, yeah, the API test one is nice. It might be a little big for this one, but I do love the API test one. So just to let you see the structure of the whole thing. Okay, there you go. Here's the program, nothing big. That's the To-Do Fluent app, and then you have all the actions. Okay, since API test was the first one that at least that I see, let's have a look at this one. from the YAML side, it's very easy. Let me check if I can do this a little bit bigger. It's very easy. You have a name, you have a description. You have to pull in your base URL, so at least the script knows which point to fire, and you get a result in the end. So that was the warm and cuddly part, and now this one is indeed a little bigger. So we are up to 371 lines. But let me see if I can. Those are all the test cases. What you can do is get health, you do check, it's supposed to be a 200. You can get a version. I simplified it to say it has to have a version, a build number, and an environment. But of course, you can also pass in the number and verify it here. Then just do all the CRUD operations, get to-dos, add to-dos. And I think this at least is very simple to understand. This one we could change to have a codable, but for testing, you all know what Swift looks like, and I think it's very easy to understand what you're doing here. And in the end, I'm just saying, okay, run all of the tests. And this, of course, you can have a very long look at it. I will post the Git repository in the end so that you can have a look, because it's public and I don't want to keep this from you. Okay, I already see deploy notification. Yeah. Okay, deploy notification. This one is a little bit more tricky. I do need to get a few things in. So you get a status, you get the environment, you need the version type, yes, and then it basically just writes a small note to you in GitHub. So nothing that fancy. It sounds great, but it's yeah. Kayla, I see you have quite a lot of questions. So I'm not sure what the timing is. I actually.
It depends on the content you have, but yes, we can start to take questions. It's mostly question from Michaela to get the PDF of the presentation after the meetup. I don't know if it is something you can post on the forum or on the Slack.
Sure. Yes, of course. I will also have a link for. So this is in my personal Git repository. It's public, so you can all have a look and yeah, find errors in the code or whatever. I'm pretty sure there are better ways to do some things, but yeah.
So these are not really questions. API tests, deployment notification, create release branch. These are suggestions for new actions.
I do see the question for the execution for tests. It is in sequence. It's just an
so are the
array.
tests executed in order or randomly?
Yeah. Well, right now it's a list of it's an array, and it starts from the beginning and it ends at the end. So there might be something more interesting to have in between. But for this simple app, I wanted to see if there are to-dos, then add some, delete some, add some more, and delete them all, just to make sure. But yes.
Andrea is asking the question, and I was thinking about the same. I noticed that you're using Swift scripts. So what is the reason there?
Yes. Well, the Swift script, so let's say the Swift executables are nice, but you have to compile them. I do have a few tools, and just for the GitHub action, it's a pain in any case to work on GitHub actions. It doesn't matter if it's Swift or if it's any other language, because you have to rerun in the CI, and you have to make sure that they're still running correctly and all this. With the Swift scripts, it actually is a lot easier. You can understand it right, and it can be executed. If you want to have this all in Swift executable, it will take more time. You either have to compile them with another action before, and then put them in the repository, or pull them from cache or whatever, and then execute them. But this would be the easiest way and the closest way to actually using a bash script.
Mm-hmm. But how works the debugging? If we want to modify them, you test them locally, you test them on GitHub?
Have you heard of print statements? So I do have I do work on a tool to look at all the different GitHub actions you have, and then use the YAML file to find out what the correct execution is, and then actually use a Swift compiled command line tool to give you a list of all the actions that could be run, and then fill in all the details. It should work locally. The only thing is that I do have a few environment variables and secrets. So maybe let me see if I can quickly jump into it, because of course. So let me see. So this is all the things that are supposed to run through, and I guess I messed up the first one. Nevertheless,
yeah, it's the very beginning of the pipeline.
Yeah, I guess there are still some things I have to improve. But for this one, this ran today, and it creates a branch, and then you have all the different steps in the deployment, monitoring, deploy to production, and then depends on where you're going here. If it was successful, then it will create the release branch. If not, it will clean up on the tags and of course the branches. So, but the reason I got in here is you have environments and you have production and staging. Both of them, I know this is not ideal. Both of them have different values in it, and it's supposed to be like a spreadsheet. Would be better to have them right next to each other, but of course it has to be a little bit more complicated. And here you can see I have the SSH hosts in here, the user, and I do have a few things I need to run the whole operation. This would be something that is a little bit more difficult if I want to run those locally, but you can always have an .env file for those, which might work. Yes.
Cool. That shows once again the flexibility of the Swift programming language, from embedded device like we had in the last meetup, Android, server side, and script. I think it's one of the first example we had of a script-based application here.
Yeah, all the products or the projects I was in, they always use Bash or Ruby or I don't know, whatever. And I can be so much more efficient and so much better if it's Swift. And now, yeah, Fastlane, same thing. So this, everyone should be able to understand what actually is happening, and then you can debug it together. And it's not just a one-person thing.
Any other question? Feel free to drop your questions. Otherwise, we'll thank you, Moritz, for the presentation.
You're very welcome.
And yes, drop your GitHub URL in the comments, so it will stay there as a reference forever. we can find it also easily. Oh, sorry. You had
no, all good.
Future?
Yeah, okay. I'm too nervous for today, so future. Why isn't this? So spread the word, of course. I do love a good documentation, but I'm still lacking behind it. There's some optimization. I saw that we had some nice blog posts on Swift on Server page for optimizing the build process, but sadly that doesn't really work in every case. And I would love to have it for building the Docker Compose inside. So right now I'm also caching the dependency step before. I still have a few things, and universal rollback would also be nice, because right now it's only working for my setup. It's not working for everything. And yeah, of course, I'm open for ideas. And this was a last minute thing, because I totally forgot about it. I saw Andre.
That's the best moment to prepare your slide. 10 minutes before starting the presentation.
I think many speakers do that.
Yeah, no other person in the audience.
Most important thing to get recognized. And with that, of course, thank you. And thank you, of course, for you two to host me. And you're more than welcome to contribute.
And contribution is not always with code, just giving feedback, saying, hey, it works well, or we need that. That's important to mention as well. Contribution, it's documentation, it's bug fix, it's IDE feedback. So contribute to open source in general. Talking about open source.
We have a very important cornerstone of the ecosystem, the VS Code extension for Swift. For that, we have Adam and Matthew visiting us to talk about, well, and answer any questions you may have, or I may have, about VS Code.
So we saw already a couple of questions arriving in the comments. So Matthew and Adam, maybe you can very briefly introduce yourself. Who are you? Why are you here tonight to talk about VS Code extension? Why you?
Sure, yeah. So hi, I'm Matthew. You might have seen me around on at least the VS Code Swift GitHub page and the Swift forums and stuff like that. I'm part of the team at Apple that's maintaining the open source Swift extension that was graciously donated by Adam Fowler and the Swift Server Working Group to SwiftLang, so that it can be maintained in that space and uploaded from official Apple sources. So we're here today just to chat about, to answer any questions that you might have about VS Code, and especially get an idea of what the community wants to see in the extension that maybe isn't there, or maybe even tell us what you like about it, what you like to see improved, and any questions you might have about how it works, or what you want to see in it.
So let me scroll back into the question. I think the first one was from you, Janice.
Yeah, OpenVSX. I would like to be able to use this with Cursor or another.
With Kiro.
Yeah, sure.
I can take that one. So we need to get approval before we can officially publish it on OpenVSX. We are pushing the people who would make that approval decision about as hard as we can, but there's not really much of an update on that other than we're just doing everything we can to bring it to OpenVSX. But what we've been doing for a good number of months now, just to at least give you guys an option for these other IDEs like Cursor, is on the GitHub releases. We are publishing the extensions Visix bundle. You can also download them right from the marketplace in VS Code as well. So it is possible to run the command in Cursor to install the Visix and manually do that. We know that's not the most ideal situation, but at least it is an option for now.
Yeah, this is what I do on Kiro, download the VSX, install manually, but then I have to redo that every time there is an update, which is not every day, I admit. But once it's there, it's working perfectly fine. We also have to manage the dependencies manually, so we have to install the LLDB extension manually.
Yeah, that one's a bit more annoying because you have to pull it from the marketplace. I don't think it's published anywhere, unfortunately. But yeah, we're working on getting that all through. We know the community really wants it, and we're pushing. Like Adam said, we're pushing as hard as we can to get that out soon. But unfortunately, we don't have a timeline on that. So.
I wish it was better integrated into the development process. Most devs aren't even aware that Swift for VS Code is a thing, especially those who are iOS focused. That's true. If you're coming from an Xcode world.
Yeah. I think the focus of the extension right now is more so on server-side development, especially like we do support iOS projects in the sense that like if you get the compile commands going, you can get language features working. But beyond that, we don't support like the simulators or anything like that because that's kind of baked into Xcode and not something that we can rely on, I suppose. That could change under VS Code's feet at any time. But yeah, certainly getting the word out there would be nice to have more people using it.
Janice, you have questions? I have one, but I'll let you go first.
Yeah, I think it would be really awesome to have a remote debugging story around Swift with VS Code. I think that's very valuable for both server use cases, like being able to debug a container that you're deploying, as well as being able to remotely debug an Android app or maybe a Linux device, or
Yeah, being able to do that would be great. I think there was, as far as like LODB DAP, I believe supports all of that. It's just more of like we'd have to expose it in the Swift extension. Right now, it's quite difficult to set it up, but I believe it is feasible. You just have to know what the magical, LLDB commands are to do it. But certainly, yeah, it'd be fantastic if we could support that.
Like LLDB. Sorry, I was gonna say LLDB DAP does allow you to attach to a remote process now, but like, yes, I agree. It would be good to like have more of like a uniform story of like helping launch remotely, attach and stuff like that. Best thing for like a lot of requests like this, if you can like raise a GitHub issue or talk to us and like get a better idea of what that like uniform workflow would look like for you, that would give us a lot more just to kind of figure out what all the pieces we need to put together.
Mm-hmm. Sebastian?
Yeah, one of the questions I had is about the roadmap, because for me, the extension works for my workflow and the things I'm doing usually. As I said at the beginning, I know the extension is doing probably many more things that I'm never using or touching. That's why I would like to see your demo to see how you're using it. But what are the things you're either working on now or thinking about adding later? What is missing? What is the big things that are missing according to the feedback you have from users?
Adam, do you want to take? I believe you have some stuff actively working on right now for playground support.
Like as far as like a roadmap, we do actually have like a Kanban board that is publicly visible. I just don't think a lot of people know about it and look at it to see like what's in the backlog, what do we have queued up to work on next, and what's actively in progress. Yeah, there's like a few things we're working on now. A lot of it has been lately like stabilizing and just kind of improving certain workflows. Like, oh, there was a lot of like friction with debugging and stuff like that. So we did a lot of work this last year to like improve those existing things. And then more recently, just new features coming to the toolchain, trying to support them. So there's like an open proposal now for like playgrounds and like Swift PM. So just doing pieces like that as well as they come into the toolchain, to be clear.
Yeah, we don't have like an official sort of roadmap right now, but it's like something we're trying to work on more is being a little more transparent in that area. So we actually did a VS Code demo not too long ago, a couple of weeks ago, where we showed off some of the features just to people that really wanted to join in. We'd love to do more stuff like that with the community and be a little more open with exactly what's going on behind the scenes, what we'd like to work on next. So that's definitely somewhere where we can improve a little bit. Because right now, yeah, we just sort of have the project page going, which sort of tracks like what we're working on, but we haven't really posted too publicly about what's going on there. So.
I think everything was always like available there. Like if you look through the issues or whatever, you could see everything we were working on, but we're doing a better job of broadcasting what that is. So we've been trying to put out like a weekly blast of what are some things we accomplished last week and what are we, new issues we're tracking and what we're planning on doing in the next week. We did do, like Matt said, like a meetup that we're going to try to do on a more frequent basis. We have no problem hopping on to these Swift server meetups and interacting with everybody. So yeah, just trying to like broadcast more. A lot of people might not seek out that information, so it's doing a better job of like broadcasting that stuff just to get it to you.
Communicating about what you're doing.
I think you're doing an increasingly good job at that. So my compliments.
Thank you.
Thanks.
Moritz, because you're still on camera, so you're one of the few that can talk today. If you have any questions, Andrea, same for you. If you want to join the conversation, you're more than welcome.
Yeah, I think the thing that I'm usually fighting for the whole Swift on server stuff is the fight that I have to fight in my company as well. They're all Kotlin nerds and TypeScript enthusiasts, and I'm the one who comes from a mobile platform and wants to show them, hey, Swift is awesome, use it. But it's a really hard sell if nobody is showing it, and I think it's sometimes very sad to see that when you are on the Server-Side Swift conference in London, you see so many companies that have used Swift in so many places, and I'm pretty sure Apple is using it almost everywhere, probably, hopefully, on the server side, and it would be awesome to get a little bit more of that feeling so that others can join. But yeah,
that's part of showing what Swift can do on the server, and the contribution from team with the server-side Swift conference, this meetup, the blog post. We have another question about, I guess it's related to yours, Janice.
This other question.
Yeah, I'm looking at how to get Swift run ---- debugger to support remote launch and debug.
That's from Doug, who works on the Swift PM team.
Ah, okay, yep.
So you have some context.
So looking forward a full demo for the next meetup.
Yeah.
Presentation, demo. Maybe go a bit inside how it works behind the scene as well. Because I'm curious. I don't know much about TypeScript and Visual Studio Code extension. So that might be a way.
Sure, yeah, we'd love to give a presentation on how all that works and give a few demos to show off some of the newer features, similar to what we did in the previous VS Code meeting that we mentioned, just to get the word out there and get more people using it and giving feedback.
And let's finish with open source. And Janice, something important.
Yeah, so FOSDEM is coming around the corner again, and folks are creating a community event at FOSDEM. I think Friday, the 30th of January, right? Stefan van Impe is organizing that together with, I think, Karen Chu from Apple, and I'll be there, and we'll have a gathering of folks interested in Swift, either newcomers to Swift or people that are already using it like yourself. So if you're in the area or want to join us, then feel free to click the link and join us. See you there.
Yeah, it's a very European-centric thing. I know some of you are watching from India, from Nigeria, we are lots attending from Canada tonight. But last year in Brussels, we had someone flying from Sydney, from Australia. So FOSDEM, if you don't know it, it's the largest open source conference in Europe. It's a very geeky, special vibe type of place because it's not like a commercial conference. It happens in a university in Brussels, and all the big open source projects and actors are there. So it's a nice occasion if you have the ability to travel to Brussels for that weekend. It happens from Friday to Sunday. Join us. I'll try to be there as well. And there is something else from Steve that says Swift devs using TypeScript to improve our developer experience. Yes, that's one of the lessons learned with you folks. So thank you, all of you, in reverse order of appearance. Yes, 8,000 more attendees at FOSDEM. Thank you, Stephen. Yes, it's huge. It's really big,
and it's a lot of fun. And there's a large variety of subjects to learn from, even outside of Swift development, like robotics, electronics, whatever.
and excellent street food and French fries. That's
Yes.
I have to sell my city, Brussels. Thank you. In reverse order of appearance, Adam, Matthew, about Visual Studio Code. We are taking an appointment with you for next year. And then also in reverse order of appearance, Moritz, Andrea, and Johannes and myself for this 7th Swift Server Meetup. The next one will be probably around March, Johannes, end of Q3 26.
Q1.
Enjoy the winter holiday for, if it is winter on your side of the world. It's not always the case. And see you next year. Bye-bye.
Bye-bye.
Thank you very much. Ciao.